We'll be learning how to write the equation of the circle in standard form as well as in general form. So first, what is what are the two forms of the equation of a circle? So the standard form of the equation of the circle is written as x minus h quantity squared plus y minus k quantity squared is equal to r squared, wherein the letter h and the letter k represents the coordinates of the center, while r, so something, of course, represents the radius. While the second form is the so-called general form, wherein the equation should be written in the form x squared plus y squared plus tx plus ey plus f is equal to 0. So in order for us to obtain a general form, we must first convert properly the data from the circle in standard form. So let us first master how to transform the data from a circle in standard form. Let's have these examples. So here in our figure, the center has the data or the coordinates 2, 4, while our radius is said to be 5 units. So in order for us to convert this into standard form, so we must keep in mind how it should look like. So it is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So minus h can be treated as the inverse of the abscissa from our center, while minus k can be treated as well as the inverse of the ordinate from our center. Thus, if we do have 2, 4 as the coordinates from our center, therefore, the standard form of this circle is x. So, inverse of positive 2 from our center, we will be writing negative 2. So, negative 2 squared plus quantity y, then inverse of positive 4 is negative 4. Quantity squared is equal to r representing the radius, and our radius said to be 5 units. Then we square it. So from this data, so what we just simply need to do next is just simplify our radius. 5 squared is said to be 25. So therefore, the standard form of the equation of this circle that we do have now is x minus 2 quantity squared plus y minus 4 quantity squared. So that's it. So that's how easy we convert the data from a circle into standard form. Let's have another example. So example number 2. So from our figure, here we have the center 3, negative 3, and a radius of 4 squared of 3 units. Let us now write this data into standard form of our equation. So first, we substitute the data that we do have here from the center towards our equation. So we do have here x, then the inverse of the abscissa. So what we do have is positive 3. So we will be writing the inverse of it, or the additive inverse of it to be specific, which is negative 3. Quantity squared plus y, then the inverse of the ordinate, which is negative 3. So we will be writing positive 3. Then equals to the radius. Our radius here is 4 square root of 3. Then we square this based on our equation. So next thing, so we just simply copy again the left side of our equation. So we're not going to make any further simplifying on this part. What we need to further simplify is the right side, or on the part where we do have the value of the radius. I forgot to write the square. Okay, so if whenever that we're squaring this kind of number, wherein we do have a whole number in a radical, so we apply 2 or the square to each number. So we do have 4 squared, we do have 16. And whenever that we are squaring a square root, automatically it resulted to just only the radical itself. Then we multiply these two numbers, 16 times 3, therefore what we do have here is 48. Okay, so this is the standard form of our equation of this circle. Let's have example number 3. Last example in getting, or rather writing the data into standard form. So here our figure, our circle have a center of 0, negative 1 with a radius of 2, square root of 10 units. So let us now transform this data, or to put this data into standard form of equation. So first, we do have the abscissa. the inverse of the abscissa. Notice that our abscissa is 0, therefore we're not going to have any more quantity anymore here. So we're simply going to have x squared because we have no number to place here because it is 0. Okay, so keep that in mind. Plus, so our y, so we do have here still quantity because we do have a specific or definite value for our y, which is -1. Again, having the inverse of the ordinate, so we do have -1. So what we'll be writing is +1, quantity squared. Then the radius has the data of 2 square root of 10 units, and we are to raise this to the second power based on our formula or our equation. So we just simply copy the left side of our equation, no changes to be made here, since we're talking about only the standard form of the equation. Okay, so we now apply the square to both numbers inside the quantity. So we do have 2. 2 square means 2 times 2. We do have 4. Then the square root of 10, again, whenever that you are squaring a square root, it always results to just only the number inside. So 4 times 10, therefore, that gives us 40. So this is how we transform the data from a circle into standard form of the equation. Okay? So let us now learn how to have the general form of the equation. It's a continuation. So earlier, we had the transformation of this data into standard form, which we do have x minus 2 quantity squared plus y minus 4 quantity squared equals 25. So this is the standard form. So let us see how we are to transform this into general form. So general form, we are to have this form of the equation, x squared plus y squared plus dx plus ey plus f equals 0. So normally, this part of the equations are to be simplified by applying the square. So by expanding them. But I'll be using a different approach. So since we need to have x squared plus y squared, and our x and y here are just only in the first degree, so there will be no problem. We instantly write x squared plus y squared. Now, next, for the first degree term of our x and first degree y, so what we're going to do is just simply multiply the constant term by 2, then attach the variable present on that quantity. So we do have here -2, so -2 times 2, again, we're just simply going to double the result. So -2 times 2, so that gives us -4. Since that value came from the x quantity, so we're going to have -4x. Next one, for the y part, so we do have -4 here, times 2 again, so that gives us -8. And this one came from the y part, so -8y. Okay, so we are done with the first 4 terms. So how about on the last one, which is for the constant part? So for the constant part, first we transpose 25 to the other side of the equation. So as you will see from our general form, there should be nothing left on the right side of our equation, so plainly 0. So therefore, we are going to transpose 25 to the left side. So that positive 25 now will become -25. Then we're going to add a couple of values coming from the square of the constant term that we do have on our quantity. So first, the square of -2 means -2 times -2 is +4. So we're going to add that, +4. And the square of -4 on the y part, so -4 times -4 is +16. Okay? Then equals 0. So the last thing, we just simply simplify or to combine all of this constant term that we do have now. So -25 plus 4 plus 16, so this gives us -5. So therefore, our general form is, so we just simply copy the second term, the second degree terms, as well as the first degree terms. So x squared plus y squared minus 4x minus 8y minus 5 equals 0. So this is how we can possibly transform the standard form into general form of a circle. Let's have another example. This is something that we already had earlier. Again, we managed to transform this data, the center had, which is 3, -3 in a radius of 4 squared of 3 units, into this form: x minus 3 quantity squared plus y plus 3 quantity squared equals 48, which is the standard form. So how are we used to use this data into general form? So again, keep in mind how our equation should look like. So first two terms should be a second degree term, followed by the third term and fourth degree, which should be the first degree terms, then last to be the constant, then be equated to 0. Again, so since we do have here plainly x and y, so our first two terms will be just only x squared plus y squared. Next, for the first degree terms, for the x part and for the y part, so we just simply multiply our constant term by 2. So -3 times 2, so that gives us -6. Since it's something that came from the x part, so -6x. Next one is for the y part. We do have here +3 times 2 again, so that gives us +6. It came from the y part, so +6y. So done with the first four terms again. Next, for the last term, for the constant part. So first, we transpose our constant on the left side. So what we do have here is +48, becoming -48. Then we attach two numbers, which will be coming from the constant numbers that we do have, so to be squared. So -3 squared, meaning -3 times -3. So we add +9. Then another one from the y part, our constant from the y part, +3 squared, meaning +3 times +3, that gives us +9 as well. Then equals 0. So simplifying the constant part, -48 plus 9 plus 9, that gives us -30. So therefore, the general form rather of this data, of this equation, is x squared plus y squared minus 6x plus 6y minus 30 equals 0. Hope you're starting to understand the process, or the step-by-step process in getting the general form of the equation of our circle coming from the standard form. Let's have one more last example for this. So here we had the transformation of this data, center having 0, -1 as the coordinates, and a radius of 2 squared of 10 units, into first in a standard form. So let us now transform this into general form. Keep in mind again how our equation should look like. So here we do have x squared plus y squared plus dx plus ey plus f equals 0 first. So we write x squared plus y squared. So no problem for that part. Next is followed by the first degree terms from x and y. But notice that our x is not accompanied by a constant term. Therefore, we're not going to have a first degree x anymore, since we don't have a constant term for x. But we're going to have the first degree term for y because we have a constant term for y. Again, to get the first degree part, we just simply multiply the constant term by 2. So 1 times 2, that gives us 2. So since this number came from the y part, so we're going to have positive or plus 2y. Again, there is no first degree x because our x has no constant term. So next one, let us now deal with the constant. So first we transpose our constant term here on the right side to the left side. So we have +40 becoming -40. Then we are adding the square of the constant term that we do have. So on our x, we don't have constant term, so we're not going to add a constant term from x, but we're going to add constant term from y. So 1 times 1. So we are to multiply to itself, so we're going to have 1. So plus 1 equals 0. So we just only have two constant term here to combine. So -40 plus 1, that gives us -39. So therefore, our general form is x squared plus y squared plus 2y minus 39 equals 0. Okay, so hope you understand now how to get the standard form as well as the general form of the equation of the circle using the given data. So now let us have the reverse. So let us now reverse the process to wherein the given now are the equations and we are to extract the center and radius to where it came from. Let's have these examples. Okay, so let us determine now the center. So it is easy to determine the center and radius whenever that the given equation is written in standard form. So for example, in this one, so we do have x plus 6 quantity squared plus y minus 7 quantity squared equals 49. Remember that on the process of getting the equation, we are just simply having the opposite values to where this originally came from. So therefore, if we do have positive 6 and negative 7, therefore, this originally came from negative 6 and positive 7. So we are just simply using the opposite sign of our constant term inside the quantity. While for the radius part, we just simply get the square root of our constant, which appears on the right side. So the square root of 49 is said to be 7. So this is how we extract the center and radius from a given standard form of equation of a circle. Let's have another one. Let's have this one. So x minus 8 quantity squared plus y minus 1. So the opposite of negative 8 and the opposite of negative 1 are the center of our circle. So we do have 8, 1 as our center. Then for the radius, again, we just simply get the square root of the constant term on the right side. So the square root of 100 is obviously 10. So we do have 10 units here. Next one, let's have the third one. X plus 3 quantity squared plus y squared equals 50. For the center, so we use the opposite of this constant term. So positive 3 is negative 3, but on our y part, there is no existence of a constant term. Therefore, what we do have here is 0. So therefore, our center here is negative 3, 0. So 0 because we don't have a constant term for our y part. Then the radius, we just simply get the square root of 50. So this won't be an exact value, so this requires factoring. So upon factoring, so we're going to have here the square root of 25 times 2. And as we all know, the square root of 25 is said to be 5. So therefore, the answer is 5 square root of 2. No, so 5 square root of 2 units. Let's have last example. X squared plus y squared equals 180. There is no constant term for the x part as well on the y part. Therefore, our center is 0, 0. For the radius, again, just get the square root of 180. Since this is not a perfect square, or will not give us an exact value, so this requires factoring process. So we just simply further simplify this. So this can be factored using the numbers 36 times 5. So 36 times 5 will give us 180. Then the square root of 36 is said to be 6. So therefore, our radius is originally 6 square root of 5. Okay. So it is really easy to determine the center and radius once the given are written in standard form. It becomes quite not that easy once they are written in general form. But it is still possible for us to get those. Let's have a couple of examples for this one. Okay. So as what you are seeing right now, what we do have here are general form of the equation. So first, let us determine the center. So to get the center of the circle that is written in general form, so we just simply use the constant part or the first degree terms, then divide it by 2. So divide the numerical coefficients only by 2, then use the opposite sign of the answer. So here we do have negative 12 divided by 2. So the answer is negative 6. So we will be writing the opposite. So positive 6. While for the second number or for the ordinate, so positive 8 divided by 2 is positive 4. We are going to use the opposite sign. So we will have now negative 4. So therefore, the center is 6, negative 4. So how about for the radius? So for the radius, here are the steps. So step 1, we transpose the constant term, which is positive 3 here, on the other side of the equation. So therefore, that positive 3 now will become negative 3. After doing that, you add to the two values coming from the square of the numbers of our coordinates. So we do have here 6. So 6 times 6 is 36. So we add 36. Then Negative 4 times negative 4 is positive 16. So next we combine all of these numbers. Negative 3 plus 36 plus 16, so this gives us 49. Then the last thing, we now get the square root of 49. So therefore, the square root of 49 is 7. So therefore, the radius said to be 7 units. So these are the steps or the process in determining the center as well as the radius of the equation of a circle written in general form. Let's have another one. So x squared plus y squared plus 4x minus 14y minus 11. So step 1, to get the center, we just simply use the first degree terms that we do have here, then divide it by 2, then use the opposite sign of the result. So positive 4 divided by 2 is positive 2, then opposite of positive 2 is negative 2. For the y part, negative 14 divided by 2 is negative 7, opposite of negative 7 is positive 7. So our center is negative 2, 7. How about for our radius? Again, for the radius, step 1, we transpose the constant term to the other side of the equation. So here we do have negative 11 becoming positive 11. So equals positive 11. Then we add the square of the coordinates that we had from the center. So we do have negative 2 times negative 2 is positive 4. And 7 times 7 is 49. Then we add all of these numbers. So 11 plus 4 plus 49, this gives us 64. Then the next thing, before we put that to our radius, we need to get the square root of it. So the square root of 64 is 8. So therefore, the radius said to be 8 units. So not that easy, but not that difficult as well. Let's have two more examples. So x squared plus y squared minus 20x plus 20 equals 0. So to get the center, we first divide the first degree terms here. So here, on our case, we do only have a single first degree term, negative 20x. So just only for the x part. So therefore, since we don't have a first degree term for our y, so automatically, the coordinate for that one is 0. So for x, so we divide it by 2. Negative 20 divided by 2 is negative 10. Using the opposite sign again, so we are to write here positive 10. Next, for the radius, we transpose first the constant term to the other side of the equation. So what we do have here is positive 20. Therefore, it will become now negative 20. Then we do have two more data, two more values coming from the square of our coordinates. So 10. 10 times 10 is 100. And from 0, 0 times 0 is 0. So just simply add 0. So of course, we may no longer write that plus 0. So negative 20 plus 100 plus 0, the answer is 80. So 80 is not the radius yet. So we need to get the square root of this first before we have the radius. So the square root of 80 is not a fixed value. So therefore, we may apply factoring here. So we can have 16 times 5. And the square root of 16 is obviously 4. Therefore, what we do have is 4 square root of 5 units. Okay, so the radius is said to be 4 square root of 5 units. Hope you are starting to get used of the process. Let's have the last example. So x squared plus y squared plus 16y minus 26. Again, for the center, we get the values from the first degree terms. So here, we only have a single first degree term that is present on the y part. So we don't have the first degree term for x. So therefore, our first value is 0 for the center, since it is x that is missing. So for the y part, we have positive 16 here. Again, we are to divide it by 2 and use the opposite sign for the result. So 16, positive 16 divided by 2 is positive 8. Opposite of positive 8 is negative 8. So our center is 0, negative 8. For the radius again, step 1, we transpose the constant term on the other side of the equation. So what we do have is negative 26 becoming positive 26. Then we do add two more data coming from the square of our coordinates. So 0. So 0 times 0 is 0. And negative 8 times negative 8 is positive 64. So adding this up, so we do have 26 plus 0 plus 64. So this gives us 90. So, next thing, to finally get the radius, so we get the square root of 90. So, this is not a perfect square, therefore, we need to do factoring. So, we do have 9 times 10. The square root of 9 is 3. Therefore, we do have here now 3 square root of 10. So, the radius is 3 square root of 10 units. Okay? So, hope you understand how to transform the data from a circle in standard form as well as in general form and be able to reverse the process and get the center and radius data from a given equation, whether they are written in standard form or even in general form. So, thank you for watching. So, see you next time. So, please like and subscribe.